So today I want to talk about spinning bullets and gyroscopic stability. Okay, this topic is kind of motivated by some of the newer state-of-the-art long-range bullets that are coming out are pretty long and have, serious twist requirements. You got to spin those suckers fast enough that you're getting all the performance out of them. And to know what twist rate that is in any circumstance of elevation and muzzle velocity, there's a lot of factors that influence stability. It's best to use a formula, like an online calculator. Burger Bullets has a twist rate stability calculator on the website. There's one built into the AB Quantum app, and it takes all of the relevant variables and calculates a number. And the idea is that you want that number to be 1.5 or higher, and you have stability. All right, but what does that mean? That's what I want to get underneath a little bit, is what does that 1.5 number mean, and why 1.5? All right, so the stability factor is just a ratio of the forces that are acting to stabilize your bullet compared to the forces that are destabilizing, or the influences that are destabilizing. So the influence that stabilizes your bullet goes in the numerator, and it's basically just the RPMs and the mass and the inertia of the bullet, like everything that characterizes the rigidity of the spinning mass. Okay, like a top, we know that spin it faster, more stable. If it's heavier and spinning at the same speed, more stable. So that's the numerator. In the denominator of the formula are the destabilizing influences on the bullet, like the aerodynamic pressure is concentrated on the front of the nose, and that's acting to try to flip the bullet over. Okay, it doesn't have veins or feathers or a tail. So the center of pressure is acting to try to destabilize the bullet, and the spinning mass is acting to stabilize it. And the comparison of those two forces are going to tell you whether the bullet's stable or not, and how much. All right, so a stability factor of 1.0 would mean that the stabilizing influence and the destabilizing influence on the bullet are balanced. Okay, they completely cancel. And in that case, a lot of times the bullets will keyhole, or sometimes they tumble, and it's not stable. It's at the beginning of stability. Between 1.0 and 1.5, you have like a gray area of marginal stability, where the bullet is flying mostly point forward, but with a lot of yaw, reduced performance. But if you get to a stability factor of 1.5 or higher, in other words, if the stabilizing influence on the bullet gets to 1.5 times the destabilizing influence, that's when most bullets really lock in and get all of their performance. If your stability factor is 2, that means the stabilizing influence is twice as much as the destabilizing influence on the bullet. So it's going to have, pretty minimal yaw angles in flight and close to maximum performance. So that's all. I just wanted to get under that number a little bit and say like what the stability factor number was, what it represented, and tell you a little about how to go to calculate it. So the Burger stability calculator or AB Quantum has it built in as well.